Today we're going to be looking at section 3.4, the chain rule. So to start us off, I'm actually going to review kind of an algebra concept. And the reason I want to take some time to review this is because it's a very important concept that comes up in all the parts that classically people taking calculus for the first time struggle with. So it's the idea of a composite function. So when we say that a function is composite, it can be written in the form f of g of x, which basically means that we're taking some function g of x and we're plugging it into something else f of x. So some examples of composite functions. Let's say we've got sine of 2x. So here, the inside is going to be 2x, because you can see the function 2x is being plugged into something else. Namely, it's being plugged into sine of something. So the outside function we would write as sine of x. Another example would be the square root of 2x minus x squared. Right, that would be considered composite because the inside function, what's being plugged into something else, we have 2x minus x squared. Outside function, right, what is 2x minus x squared being plugged into? Just the square root of x. And really it might be helpful, instead of writing the x in that outside function, to instead say question mark. So let's think of it as sine of stuff and square root of stuff. All right, and then another example might be e to the 3x. That would be considered composite as well. So there, the inside, the function that's being plugged into something else is 3x, and the outside function it's being plugged into is e to the stuff. So those are examples of composite functions. What would not be a composite function? Well, let's see, sine of x. I mean, you could technically argue that this is composite with the inside being x, but the rule of thumb here is that if the inside function is just x, then it doesn't really count as composite. So that would be, so I wouldn't consider that to be composite for the purposes of what we're going to learn today. Square root of just x. E to the just x. Just another one for good measure. If I had something like 1 over x cubed plus 5, that would also be considered composite. There, the inside would be x cubed plus 5. The outside would be 1 over stuff. And the non-composite version of that would just be 1 over x. So those are all examples of functions that are composite on the left side or not composite on the right side. Other general thing, if we're able to use something like the power rule or any of the other rules that we've learned thus far to find its derivative, then it probably isn't composite. So like 1 over x, we can write as x to the negative 1 and use the power rule. 1 over x squared, we could also write as x to the minus 2 and use the power rule. Sine of x, we know the rule for that. It's cosine of x. Natural log of x, we know the rule for that. Derivative is 1 over x. So one of the big things that you're going to want to master moving forward is being able to look at a function and tell if it's composite or not. So what is the chain rule? Well, the chain rule is essentially just the rule that we use to take the derivative of a composite function. So if y is equal to f of g of x, so we have the inside function g of x, the outside function f of stuff, right? Then the derivative y prime, or dy dx, is equal to f prime of g of x, so notice the inside doesn't change, multiplied by g prime of x. And if you think about it, technically you've also been doing that with things like the product rule, or the power rule. Because when I take the derivative of x squared, right, I get 2x times 1, which is the derivative of x. I mean, you don't have to remember it like that. But it is kind of a justification that we've technically been using this the whole time. But anyway, let's look at some examples that require this. So if I go back to some of the examples we wrote out, let's say if I want the derivative of sine of 2x, then y prime is going to be sine of 2x. Well, not sine of 2x, the derivative of sine. Derivative of sine is cosine of 2x multiplied by the derivative of 2x, which is 2. Typically, when we multiply by numbers, we put them in the front. So that's the derivative. Another example. Let's say that we want to find the derivative of, what's that other one? The square root of 2x minus x squared. Okay, before I take the derivative for this, it's going to be really a lot easier for me if I rewrite that square root as a power. So everything inside the square root, we have 2x minus x squared is being raised to the power 1/2. So if I were to write out my inside function and my outside function, the inside function would be 2x minus x squared. The outside function would be stuff to the 1/2. So if I take the derivative of the outside function, I get 1/2 times stuff to the minus 1/2. Here in the place of stuff, I'm just going to put what my inside was, and we take 1 away from the power. And then, because of the chain rule, we have to multiply that by the derivative of the inside. So the derivative of 2x minus x squared, we get 2 minus 2x. And that is my derivative y prime. Other side note, because your homework a lot of times is multiple choice, you can always rewrite these. So what I mean by that is because this 2x to the minus x squared is raised to a negative power, we can always bring it down to the bottom. So it'll be 2 times 2x minus x squared to the now positive 1/2. Right, when we move sides in the fraction, we change signs on the exponent. And then because I'm multiplying by 2 minus 2x, I can write that in the numerator. 1, the thing that's already in my numerator, times 2 minus 2x, we get 2 minus 2x. So that's another way you could write it. Another way, even more, that you could simplify this is you could factor a 2 out. Right, and then you've got right, and then you've got a factor of 2 in the numerator and the denominator. So that'll divide and leave behind a 1. Right, and the final way that you could do this, and what you would probably see as an answer choice, is you can rewrite that 1/2 exponent as a square root. And that would be the most simplified way to write the answer. All right, now let's look at some other examples. Let's say that y is equal to e to the 3x. Well, if you remember, we can write out our inside and our outside function. Inside we have 3 to the x. Outside we have e to the stuff. All right. So the derivative of e to the stuff, remember we start with the derivative of the outside, is just e to the stuff. All right, and instead of stuff, we're going to plug our inside back in. And then we multiply by the derivative of the inside. So the derivative of 3x is 3. And that's the derivative. And let's do that other one we had there, 1 over x cubed plus 5. Okay. So as I mentioned before, the inside for this one is x cubed plus 5. The outside for this one is 1 over stuff. And remember, you can write 1 over stuff as stuff raised to the minus 1. All right, so when I go to take my derivative, y prime, I can use the power rule on my outside function. So we bring down the minus. We have stuff. I'm not going to write a question mark, though. All right, the stuff being the inside function. And we're going to take 1 away from the power, minus 2. So I've done the derivative of the outside. Now I need to multiply that by the derivative of the inside. So the derivative of x cubed plus 5, we can use our power rule. That's going to give me 3x squared. Box that off there. All right, so then that's the answer. But remember, there are other ways you can write this. So I can also write this as negative 3x squared divided by, because of that negative power, we can move that factor of x cubed plus 5 to the bottom as x cubed plus 5 squared. And that's another way you could write it. And one last one for fun. And because it's a pretty quintessential one that will pop up again later. Let's say that I want to find the derivative of y equals the natural log of, let's go with cosine of x. All right, natural log of cosine of x. Well, when I go to find my derivative, I'm going to benefit from identifying what the inside and outside functions are. So my inside function is cosine of x. My outside function is natural log of stuff. So when I take the derivative of the outside, we know the derivative of natural log is 1 over x, or 1 over stuff in this case. And our stuff, remember, is cosine of x. That's the inside function. And then we have to multiply by the derivative of the inside. So if you remember from a couple videos ago, derivative of cosine is negative sine x. So remember, when you multiply a fraction by something, the something will go in our numerator. So this is negative sine of x over cosine of x. Well, if you remember your trig, you know that this can also be written as negative tangent of x. Pretty cool. And with that, we'll wrap up my video. So keep in mind the notes about simplifying your answers. Remember, your main idea here is the chain rule is a way to take the derivative of a composite function. You know a function is composite if there is an inside function being plugged into something else. From there, identify your inside and outside, and the chain rule, you take the derivative of the outside with the inside still plugged in, and you multiply by the derivative of the inside. And simplify when you can. Sometimes these will end up having kind of nested chain rules where you have to do it a couple of times. But honestly, the ones that are simple, like this e to the 3x or this sine of 2x, right, those will kind of become second nature to you as you do more and more of these. But yeah, that's the chain rule. This is something that you definitely are going to need to practice a lot because it is something that's going to come up a lot in this course and in future calculus courses. Cal 2 for sure, Cal 3 a bit too. So yeah, that is my spiel for today.